Okay, so welcome everyone to the CSE 110 Exam 1 review. My name is Karl Alcanze.
And my name is Leo.
Okay, so first we're going to present ourselves and we will go over some of the objectives for this meeting and so on and so forth. And just as a reminder, if you guys want to follow us, this is our Instagram, FSC Tutoring, and you can follow us on Facebook at Engineering Tutoring Center. Okay, so I am a sophomore in computer science, and I joined the special programs tutoring this fall in 2020.
And I'm also a sophomore, and I'm joining the special program in for 2020 as well.
Okay, so some of the objectives for this meeting is to go over some of the data types that you encounter in CSE 110, going over some of the operators and expressions that you see in your course. We will also be going over loops, conditional statements, and also methods in order to prepare you for your first exam. Okay, so first off, we will be discussing the different data types that you normally use in your course. So there's two different data types. So first off, there's the primitive data type. So this is like the bread and butter of the data types. So the simplest kind of form of data that you can have in Java. So some of them include the integer, the long, the short, the float, the double, the Boolean, and the char. And I put some of the ranges that are characteristic of each data type. So an integer, it can be within the range of, let me see, so -2 billion, I believe. Yeah, -2 billion to a little over 2 billion. So say, for example, you try to assign an integer value or an integer value for a variable x, and it was 2,147,483,648, it would not be able to run. The program would not be able to run. And the same goes for the long, the short. I was not able to print out the values for float or double because those values are very, very large. But apart from that, the Boolean has true or false as its range of values. And continuing on, we have the non-primitive data types. So this includes strings and arrays. This is mostly what you will be using in your course. So string, of course, it can store a series of characters, and an array is a data structure, essentially. Okay, so first or next, we will be discussing scanners and strings. The scanner class is something that you use often in CSE 110. So in order to actually use the scanner class, you have to import the scanner class itself. So the import statement, import java.util.scanner, you always have to include that statement in order to use a scanner. And once you import the scanner class, you can create a new scanner object. So as you can see here, scanner in equals new scanner system.in. So what this essentially does is create a new scanner object so that user input can be entered into the program. So for example, integer x equals in.nextInt. So what this does is it receives an input from the user, a numeric input, and it stores that numeric input inputted by the user into the variable x. So say, for example, you enter 10 into the integer value x, or the integer variable x. So 10 is now stored in the variable x. And the same goes for strings. So there's actually two ways that you can use a scanner class in order to input a string. So first you can do in.next, and what this does is it receives a string input from the user, but the thing is you cannot have any spaces in that input. So it essentially can only hold one word, basically. And that one word is stored into the variable input. And next, you can do in.next line. And what this does is receives a string input from the user, but it can now include spaces. So the input can be an entire sentence like hello space world. And that takes care of the scanner class. And next we move on to some of the strings and string method, or some of the string methods that you can use in order to manipulate data. So some methods include length, which returns the length of a string, char at some integer value. It returns a character at the index of x. So char at int x. If x was 1, it returns the character value at index 1. And substring, you can return a part, or this returns a part of a string that from index x to index y minus 1. And we will see some examples of these methods being put to use in the next slide. To uppercase, it essentially makes the entire string uppercase. And the same goes for lowercase. You can make a string, an entire string to lowercase. And you can compare two strings. So for example, if you want to compare apple to orange, we know that apple comes before orange. And you can think of this as the dictionary. Apple comes before the word orange. And we will see how this works in the next slide. So an example that I have here is I have string ABC, and I assign ABC to the string. I assign string CDE, CDE, and EFG to string EFG. So ABC.length. This returns the value 3 because, as you can see, ABC contains 3 characters, so it returns a value 3. ABC.char at 1, so this returns the letter B. So the index always starts off at 0, or usually does. So for the string ABC, letter A is index 0, and letter B is at index 1. So this is why when we call the method char at for ABC, it returns the B value, or returns B. And for the substring, when we invoke substring onto the string ABC, we see that it returns AB. So as we saw on the previous slide, it returns, the substring method returns part of a string from index X to index Y minus 1. So ABC, so letter A is in index 0, letter B is in index 1, and letter C is in index 2. But since we're returning from index 0 to 2 minus 1, it returns AB. And the method abc.toUppercase does what you expect. It returns a capital version of the string ABC, so it's now capital ABC. efg.toLowercase, it returns it to, or it changes efg to a lowercase efg. So next we do abc.compareToCDE. So ABC compared to CDE. It returns a -1 because A comes before C. And if we were to do BCD dot compared to ABC, it returns 1 because C comes after A. In an example string problem, sorry. So string X equals I like Java, and we have some statements here: system.outprint x.length, system.outprint x.substring 0 to 9, and system.outprint x.char4. So you can see that x.length will return 11 because this, the length method counts characters as well as spaces in this case. And substring returns part of a string. So in this case, it would return I like JA. So it starts at index 0 and prints all characters from 0 to 9 minus 1. So only until the 8th character is printed out. And char at 4 is K. And index starts at 0 once again, and it prints the character at index 4. So once again, we're always starting at index 0. And yeah, so you start from 0 and you count up until the letter K. And also the space is also included in the index values. All right, next we have operators and expressions. So arithmetic operators. The plus adds two numbers together, and it can also be used to concatenate two strings. The minus sign subtracts two numbers. The divide divides two numbers, but it does not give the remainder. And the modulus operator, or the percent symbol, gives a remainder of two in numbers after division. And the asterisk multiplies two numbers. And we will see some examples of expressions here. So as you can see here, I declared a variable x as an int value. It is 5, and I assigned it 5. And I did the same for integer y, and I assigned the value 10 to the variable y. And int total equals x plus y. So this counts as an expression. So as you can see here, we are adding x and y together using the plus operator. And this is a basic example of an expression. So when you add x and y together, you would get the value of 15 for the variable total. And so another type of expression is a string expression. So I have two strings. String A is hi there, and string B is my name is James. And we can see the expression for result, the string result, is A plus comma plus B. So when you print out the result, it concatenates all of the strings in the expression. So string A is combined with the comma, and the comma is combined with string B. So it would now print hi there space, or hi there comma, my name is James. So here's an example of an expression type problem. I have integer value c assigned to 6, the double x assigned to or equal to 7.4. I declare a double y, but I assign the y value to x plus c, or I assign x plus c to the variable or double variable y. So what would be the output in this case? So we know that c is an integer, x is a double, and when you add a double and an integer together, it will produce a double value, or a decimal value if you want to make it simpler. And the result of adding c and x together is assigned to the double y. So the output would be 13.4. Here's another example of an expression-based problem. So we have integer x set to 7, integer y set to 5, integer z set to x modulus y. So remember what the modulus operator does. It returns the remainder of the operation. When you divide 7 by 5, you get a remainder. Remember that. And the int result is our expression. So result, the integer result is z times 10 plus 5. And we want to print out result. So what will be printed out? I will give you a second. Pause the lecture if you want. Okay. So the variables x and y are declared. So x is equal to 7, y is equal to 5. The modulus operator is used between x and y. So if you look at the line where integer z is declared, we can replace x and y with the values 7 and 5. And we see that because the modulus operator is in between 7 and 5, it will return 2 because 7 divided by 5 has a remainder of 2. And now with integer results, we can assign or we can replace the z with 2 because that's what we got after the x modulus y operation. And now we can do our calculations. So 2 times 10 is 20, and plus 5 is 25. And what would the print statement would print out 25.
Now I'm going to go over the loops. So first we have three types of loops. The basic while loop. So it's just like this. And the second type of loop is for loop. It's another a similar type of while loop. The last type of loop is do while loop. So let's take a close look at the while loop. So while loop is pretty straightforward. So first we declare a variable x equal to 0. Then while x is greater, while the condition is true, then just execute the code inside of the while loop. So we just keep looping back until the condition turns to false. So we exit this loop. So what is the last value of x will be printed out in this case. First, it is initialized to 10. Step 1, the condition will check if x greater or equals to 0. And yes, 10 greater and equals to 0. Therefore, it will execute system.out.print line, print out at 10. Then the third step is x will be decreased by 2. So x becomes 8. After that, the loop will go back to check the condition again. So it will check if 8 greater equals to 0. So the loop will just keep looping back until the x equals to -2. So, but here, it will print out x before x decreases by 2. Therefore, the final x that will be printed out would be 0. So the for loop is a harder version of the while loop. So first step is initialization. We have basically three parts. In the parentheses. So on the left part we have initialization, and let's say int I equals to 0. Then the second step is check the condition. It's just like the while loop. If I less than 2, then do the body part. If not, then it will just skip this loop, just jump outside of the loop. And the third part, when the body part of the code is executed, it will jump to the third part, which is updation. You can update the loop variable. So therefore you can use the loop, take advantage of the for loop. The third type of loop is do while loop. Also, we call the do loop. So for the do loop, it's a special loop that it will execute the code first, then check the condition. So it's not like the while loop or the for loop. So first it will do and execute the body part of the loop. Then it will check the condition. If the condition is true, then it will go back to execute the body part again. If the condition is false, then it will just jump out of the loop. Okay, so let's take a look at the conditional state. So it's just a if else, and else if statement. The first one is pretty basic. It's just a if statement. So for example, if condition, then the body part. If the condition is true, then execute the block of code. If it's not true, then just skip this if statement. And the second condition is is else, is if else statement. Basically, it just add an else, add an else statement. So first it will check the condition. If the condition is true, then execute the body part of the condition of the if loop. If the condition is false, then it will execute the code that's in the else block of code. So, and we have the third type of the statement is else if statement. So basically it's just a supplement of the if statement, if condition, and else if condition is true, then execute the body part of the if. If it's false, then we check the another condition again. If the second condition is true, then we execute the block of code. If the second condition is false, then just jump out of this else if statement. So basically all of those conditional statements are the same. Just check the condition, then do or not do the body part of the code. Okay, now we have relational operations. So we use this relational operations to dealing with the conditional statements. For example, we have a double equal sign to check if two values are equal or not. And we have the second sign that check not equals to another value, and less to greater or equals to greater. So it's just pretty straightforward. It's just like the normal operators. Okay, so we have an example of if-else statement. So the first one is just an if statement. First, we declare double num and initialize it to 10.5. Then we check the condition. If num less or equals to 12, so 10.5 less than 12, so we execute the body part of the condition, the body part of the if statement. So we just print out yes, and that's all. If the num set equals to 13, then 13 is not less or equals to 12. Then we just skip this block of code. So it's done. The system will print out nothing. Yeah, it's just a steps. And the second one is if-else if statement. So we just first we declare and initialize num to 10.5. Then we check the first condition. If the num is less or equals to 10, no, it isn't. So we just continue to check the second condition. 10.5 greater than 10. Therefore, the second part of the body will be printed out. So it's just print out greater. So we notice that for if-else, okay, this is the third example, is if the simple if-else statement. So for if-else statement, after checking the first part of the condition, if the condition is false, then we just execute the else part of the code. So we will not check the condition again. We just check the condition once. So if the num is less equals to 10, in this case it's false, we just print out greater. That's how if else statement works. So move to methods. Basically, there are some methods that are already predefined that are located in Java library. We can just use them directly as long as we just import the packages. For example, the math, the methods that's in math class. The first one, math.power phi 1, which means it will return a double at phi to the 1th power, which is phi. But the power method will return a double, so it will automatically convert the integer phi to 5.0. And for and the other methods like math.absolute value, it will return the absolute value of the results that in the parentheses. In this case, 3.3 minus 5 equals to -2, and it will return +2. And the third predefined method in the math class that's pretty common is square root. So the square root 4, it will return a double as well, just like the power. And the first one is very special method. It will return a constant. So if you want to get the exact value of pi, you can just type out, you can just initialize x in double x equals to math.pi. It will store the exact value of pi into the variable you want to store. Okay, so another example of predefined method is print line method, and it's a pretty popular method that so it's pretty common, and we just you'll see to print out messages in the console. So there are some other predefined methods, but those methods are limited. We need to create our own methods. So how can we create our own methods? So for creating a method, we need a modifier, return type, the name of the method, parameter list, and the method body. Let's take a look at this example. First, public class example mean number. So public is a modifier. Oh, this is a class name. So we will take a look at this mean function method. So public static, those two are modifiers. Sometimes we can just ignore the static. This is optional. So we can just public int. So the first part is modifiers. It defines the access type of the method, and it is optional to use. So in Java, by default, the attributes and the methods are set to public. So we can also use private and int mean function as well. But in this case, it's public. So the second element of a method is a return type. We can have a return type, have like integer, double, string, or we can return nothing. So it's called a void return type. We will see that in the next slide. So, and the third part is the name of the method. In this case, it's main function and the parameter list. So in the parameter, we can have some variables to pass to receiving the numbers or the reference, or we can have nothing. And we will see an example in the following slides as well. Okay, so that's parameter list. And the part that inside this bracket is just the body of the method. So it's just tell this method to do something. Okay, let's take a look at the main method in this class. So it just declare A, B to 11 and 6, and then it create C and call this main function parentheses A, B. So here it will pass the value of A to the parentheses in the main function, which means it will pass A to N1 and it will pass B to N2. Therefore, N1 will come to 11 and N2 will become to 6. So instead of this body, it will declare an integer mean, but it doesn't give the mean and value. Then it's a conditional statement. If N1 greater than N2, if 11 greater than 6, which in this case is not, so we just jump to else. So mean equals to N1. Sorry, in this case, 11 greater than 6, so mean will set to 11. So N1 will have the value of A, which is 11. N2 will have the value of B, which is 6. So in the condition checking part, 11 is not greater than 6. So it will jump to else. It will set a mean to N.
Wait, Leo, I think you, so 11 is greater than 6. So
yes,
it would execute the if statement.
Yes, so the mean will be set to 6. So it will return to the 6. Therefore, C will be set to 6. So it will print out the mean value equals to 6. That's how we use a method. If we're using a method inside of this class, inside of the same class, we just need to call the method name and then the parameters. But if we're using a method outside of a function, for example, like here, we're calling .power method outside of the math class. So we need to add the class name math.power in order to access the method. Okay, so let's take a look at the method with no parameters. For example, toString method is a pretty common method that's almost in every classes. So even you don't define a toString method, it will have a default toString method within a class. So in this case, it defines the toString class. It just return a string. So you can say in this case, the public is a modifier, the string is the return type. Here is return a string. And toString is just the name of the method. And there is nothing inside of the parameter. So if we want to call this toString, we just use .toString here. We just use .toString, and with parameters contains nothing. And it will simply return a string. And the other example is passing by reference. So here we have simple apple class. So here, let's take a look at the main method. So first we create an object, an apple object. Then we will print out the color of the apple. Then we are calling this change apple method. So here, let's take a look at the method. We got two modifiers, and the return type is void. So this is an example of return nothing. We simply just using this method to do something, but returns nothing. So we just put void here. And the name is just change apple. And apple. So the first apple is the name of the class. It's right there. And the second apple is the name of the object. Here, it declares apple. The second apple is just the name of an apple object of the apple class, which is capital A. It's a little bit confused, but the apple inside of this parenthesis will have the reference which will have the same reference as the apple that passing into this change apple method. So in this case, it will create an apple object and pass the reference, which is the address of the apple object, into this change apple method. Then it will change the color of this apple object to green. So it will print out the color again. And the result, the first result, it will print out to red, which is original color. And after calling the change apple method, it will print out the green, the color green. So that's how. So we got in CSE 110 we only have passing by value, which is in the previous example, and here is passing by reference. And it's quite important to understand how those passing things works. Yeah, and that's all the topics we got today.